Good day, everyone, especially to our dear panelists. We are Group 9, and for today, we will present our proposal, which is the Philippine turtle shell inspired and typo resilient roofing structure utilizing bambusoidea and Iconia crassipes. According to AbuSurf and GU 2018, due to the changes in weather, roofs play an important role for absorption of solar radiation and amount of heat coming from the sun. As stated in one of the article of Designing Building Wiki 2019, roof structure also serves the protection that is made up of a system of structural members supporting the roof. To change the subject, here's the next slide, which is about bamboos and water hyacinth. Bamboos are used for great variety of purposes. The jointed stems of bamboo have numerous uses such as planks and roofs of houses for large stems, while scaffolding on building site construction for large and small stems. On the other hand, water hyacinth is described as a rhizomatous and stoloniferous plant with long pendant and adventitious roots, which is 10 to 20 centimeter high and could reach up to 1 meter high. As for the significance of the study, the results of the study will be of great benefit to the following. The result of the study will be beneficial to the typhoon vulnerable communities because this study will create a sustainable design that seeks an acceptable solution to the challenges and current problems, which is the natural calamities. Second one is the students. Data given will provide the students with information regarding the existing study about innovation and alternatives. Also, the results will enable the students to improve and acquire new ideas that could help them for researches and future purposes. As for the statement of the problem, according to the Pag-asa, due to its geographical location, Philippines is known to be prone to natural calamities, especially to tropical cyclones that brings not only rainfalls but strong winds and also flooding which result to the negative impact of human life. But then, what we really need for this problem is the urgency to build a disaster resilient home since a large scale of portion of the population lives in slum areas with no certainty of adaptability to climate change.
This research proposal is preconceived to attain the following objectives. First, to know the properties of bamboo and water hyacinth to assess its capability as construction material. 2. To formulate a roof design structure that can withstand the weather in the country. And last, to establish a roofing system that can be easily constructed with affordable and highly available materials.
And for the related literature, according to Santos 2013, he stated that since the Philippines is prone to different disasters such as floods, earthquakes, and typhoons, he suggested that the nations need to improve its homes that are resilient to this various dilemma. Furthermore, he added that the natural disaster is inevitable. What we must do is to respond and withstand against this national phenomena.
Next, according to Stephen Schroeder, he stated that the use of bamboo roofing sheet is a great deal and offers a lot of advantages than those metal, plastics, and asbestos. Furthermore, he stated that the bamboo is made from renewable and sustainable resource and offer low-cost material price, environmentally healthy and a comfortable substitute to roofing panels.
In the study of Chung and Chan 2017, they stated that over 1,500 variety of bamboo are known in the world. It can grow about 15 to 30 meters in the span of 2 to 4 months. Its cylindrical shape with a joint stem is called culm. Furthermore, it was revealed that bamboo strength and moisture content are among the most essential factors that decides both full bamboo's culm's ability and power. In addition, bamboos have an optimal resistance and are ideal for heavy-duty application. It was also discovered that the mechanical properties of bamboos increase along their height.
First is the theory of shell structures. It has existed as well-defined branch of structural mechanics for about 100 years, and the literature is not only extensive but also rapidly growing. It shall be concerned with man-made shell structures as used in various branches of engineering, like architecture building and structural engineering itself. Next is the biomimicry nature-inspired building structures. So, in this case, why did we choose this kind of material as an inspiration? especially a turtle itself is part of the nature. We based it on visual inspiration and conceptual inspiration. This study describes sea turtle shell can be utilized to shape a strengthened cement for a huge range roof. So next is a comprehensive study for different loading conditions. This study is all about effectiveness of shell structure and how the curvedness affect the loading condition. Well, the shape and dimension of roof structure used is different for different loading conditions and geographical locations, such as horizontal, sloping, or curved members such as dome and shell member. So next is the structure and mechanical properties by mimetic. So in this study, this will state additional strengths for using turtle shell as an inspiration as well.
So, for this chapter, it is said that the specific design approach is specified in order to meet all the objectives set out a while ago. First, all of the identified theories related to shell design are acquired and studied. It includes the study of the different shell surfaces, their structural behavior, and the potential ways in which they can fail. Second, the history of the Philippines has been vulnerable to natural calamities along with its location. The geographical circumstances in this country are highly vulnerable to natural disasters such as tropical cyclones, typhoons, and floods, which make the country suffer an inaccessible amount of casualties. Third, currently designed establishments that are more like shell structures are studied in order to provide a better understanding of the projected loads on the roof. The fourth one is that the pre-designed criteria are drawn up on the basis of the three phases described above. Essentially, they act as conceptual limits or restrictions only under which the designer can work freely. Some of these are the raw materials proposed in this analysis, mainly bamboo and water hyacinth. Once all considerations are taken into account, the fifth one will be the description of the main design process shall be drawn up. And finally, the evaluation of the designed roofing system if it is durable and resilient, especially the assurance if the research goals are fulfilled.
For the data presentation, the following figures are made by the researchers to present the design roofing system. Figure 1 shows phases the framework went through, from its skeletal design up to its actual design. Figure 2 shows the front view of the framework. Bamboo poles will be used to construct the framework. It will be formed by using bamboo joints, and pegs are included to pin the joints. Also, ropes will be used in order to secure the connection of the bamboos. Crescent trusses will be the type of truss to be used in order to achieve the shell-like structure. These trusses will be placed on both opposite edges and midpoints of the wall. Purlins are then placed on the rafters to support the structure, which is clearly seen to Figure 3, the top view of the framework. Next, Figure 4 shows the side view of the framework. Figure 5 contains the dimension of the framework. Considering a 4 meter by 5 meter house, the length would be 5.40 meters and 6.40 meters for its width, including the roof overhang, which is 0.70 meters for each side. The roof height is 2 meters, the space between each purlin is 0.5 meters, and the space between each web of the truss. Lastly, Figure 6 shows how the roof and insulator will be placed on the roof framework. On the left side, the insulator, which is made from water hyacinth stalks, will be placed first on the framework. Above it, roof will be placed. The roof to be used is bamboo roofing sheet, which is quieter when it rains and easy to work with. This roofing system is inspired by Philippine sea turtle, locally known as pawikan, because of its shape and structure. A turtle's carapace or the upper shell consists of large bones covered by large scales. For the structure, the roof frame serves as the large bones while the roof itself serves as the large scales.
And that ends our research presentation entitled Philippine Turtle Shell-Inspired and Typhoon-Resilient Roofing Structure Utilizing Bamboo Soideae and Eichhornia Crasps. Thank you all for your attention.